Alright, Mr. Claxton's Algebra 2CP class. We are dealing with linear programming. That's what we're going to be doing in the next section, rather. And in order to understand linear programming, you must first understand constraints and how to represent constraints, how to pull those out of a word problem. So we're going to focus on that in this video. There is an excellent Khan Academy, exercise that allows you to explore that. Really is a good one, and I'm just going to show you some of the subtleties about that, just because it is you have to get a lot of things right in order to get the problem correct. In fact, this is take 4 for me. So it's not easy. Okay, but it's a good thing because it's going to make you think through it. I'm going to help you to think through it here. So what we want to do is, you can see the first step to linear programming is to represent the constraints as a system of linear inequalities. We just have one linear inequality that we're dealing with here. I've copy and pasted the example. Okay, modeling constraints with two variable inequalities. I know that you could pause and read this, okay, and pause and look at it, and try to make the learning your own, because that's what we want to do after all. Alright, I'm glad you paused. Alright, so we see this word at least here. As soon as we see at least, think to yourself, if I had at least $20 in my possession, how much could I have? Well, I could have 20, right? Or I could have 21 or $80 or boy, maybe even $100. That'd be nice. So at least means greater than or equal to. Last year, Charles here earned 50 points in the wellness competition at work. This year's goal is to at least double his point total. So at least double 50, and you get 100, right? So we know somewhere on there we're going to get greater than or equal to 100. So when you go to that app and try to write that in, there's going to be a little emoji that's going to pop up. Okay, and he's going to pop up, and he's kind of ugly, and he says, sorry, I don't understand that. And don't stop, okay, don't freeze, just keep going with what you want to do. So greater than or equal to 100 is where we started, and then, okay, I build my, 5, R, has to be capitalized, by the way, must be capitalized, plus 2B, okay, now he's going to understand that. That's going to make sense to him, so it's after you're done. Okay, so don't stop as soon as you see that little ugly emoji. I know that's going to stop some of you dead in your tracks. So we go back to the problem. This is our constraint. In order to graph that, because then they want you to give a visual representation, right? That graphical representation. In order to do that, you got to go from 5R plus 2B is greater than or equal to 100. It helps to think about, oh, wait a second, I'm used to thinking of it as an XY plane, so R is X and B is Y, so just replace R with X and B with Y. And then solve for Y. Now I solve for Y right here and show the steps, how we subtract 5X from each side, and then divide by 2 on each side to arrive at Y is greater than or equal to negative 5 halves X plus 50. We want to run with our y-intercept. So the first thing that you want to plot is your y-intercept. Okay, so we plot our y-intercept here. I'm just going to go ahead and plot that, in black. And then it makes you, because it's an application that requires you to slide the line, it has these snap points, and it will not snap at negative 5, 2. You can't go down 5, right 2. It won't let you. So you have to either interpret the slope a different way or find the x-intercept. Okay? If we find the x-intercept here, that red axis, if we find the x-intercept, any x value, or rather any y value on the x-axis is 0. Okay? Any y value on this x-axis is 0. Okay? If you're thinking about an ordered pair, okay, that's the second part of it. We know that in a point on the x-axis, y value is 0. So I could say, well, what's going to give me a 0 for y up there? And I could determine what x value is going to give me a 0 for y. Okay? Or, you know, and if you do that, you know, it's easier just to plug it back into, okay, in this b, you know, plug a 0 back in. So 5r plus 0 is greater than or equal to 100. And in this case, we're just trying to find the intercept. So I could change that to an equal sign. So I could go back and say, okay, 5r equals 100. What does that value need to be? And you know, you're going to get that the value is 20. And that is, you know, you're finding the x-intercept there. So if you don't find the x-intercept, then what you need to do is you need to be able to interpret slope differently. And that's what I do here. I take you through, okay, negative 5 over 2 is the same as down 25, right 10. Because it will let you go down 25, right 10. So, you know, you could go down 25, right 10, or you could go down 50, right 20. You know, and that's just another way to interpret it. It is kind of, it's a little bit touchy as far as that's concerned, but that does reinforce your understanding of slope. So once you get the line graphed, it doesn't let you shade, but what you need to be thinking is, okay, if he wants to meet or exceed his expectations, well, the green line would be him meeting his expectations, and then everything, let's make that green again, and then everything above that line is going to be, you know, Charles meeting or exceeding his expectations. And it just gives us that nice visual there. Okay? Then they give you a scenario. If Charles runs 12 miles, then which of the following numbers of miles can he bike to meet or exceed his goal? Now, visually, if you're looking at this, 12 is going to be, well, that would be 12.5. 12 is going to be right here. You'd follow it straight up. You know, follow that 12 straight up to see, okay, it's going to be at about 20, doesn't include 20, does not include 20. Well, visually, if you're looking at this, you're guessing, you know, I mean, and you're making an educated guess, but in Khan Academy, you don't want to get the problem wrong. So one way that you could be exact about that is just to plug a 12 in for R. 5 times 12 is 60, subtract 60 from each side. 2 times B is greater than or equal to 40. So B has to be greater than or equal to 20. So that can help you. You know, when they do give you that, the visual representation should help a lot too, because you're going to see, okay, I know anything out here is going to be acceptable. So you would actually select all of these before you submitted your answer. Okay? I didn't, and that's why I'm doing this for the 4th time. I didn't select 20. I just kind of looked at it and rolled with it. But, you know, if you want to be exact and you want to get the stuff right, then you gotta really check yourself. And that's why I like it so much, because it makes you think. But, you know, I've explored all the subtleties with you. I'm hoping that you just get 5 in a row, right, and build that confidence and are able to hit the ground running with linear programming. So I hope this helps, and happy modeling, everyone. Be great models.